All right, welcome to Unit 3, Collecting Data in AP Statistics. Today's video is going to focus on Topic 3.2, Introduction to Planning a Study. So what exactly is a statistical study? A statistical study is a process of gathering and collecting data to learn from in order to answer a research question. So simply put, statistical studies attempt to answer some type of research question. So what are some research questions? Well, honestly, a research question could be something as simple as what proportion of people drink coffee every morning? What is the mean height of oak trees in a national park? What is the mean amount of time it takes an employed adult to get to work? Or it could be even a little bit more complicated, looking at the relationship between two variables, something like, is drinking coffee related to living longer? So we got two variables there. Do you drink coffee? How long do you live? Does eating more garlic help reduce migraine headaches? Does Scott's fertilizer make grass greener than other brands? Scott's is a brand of fertilizer, and there's lots of brands of fertilizer, but does that specific fertilizer help make grass greener? So statistical studies are needed to answer these types of questions. But to answer any of these types of questions, one of the things you have to start doing is collecting data. If I want to know the proportion of people that drink coffee, I guess I need to go around and start asking people if they drink coffee. If I want to know the heights or the mean height of trees in a national park, I guess I need to start walking around a national park and measuring the heights of oak trees. If I want to know the mean amount of time it takes adults to get to work, I guess I better be getting a stopwatch out and clock how long it takes several people to get to work. I got to go and actually collect this data. So before you do anything, when you're trying to answer a research question, just make sure you plan, right? Think about what is your research question that you want to answer. You got to have the question first. Who or what will you collect your data from? People or trees? What variables are you going to gather or collect data on? Like, am I going to ask a categorical variable? Do you drink coffee? Yes or no? Or is it going to be quantitative? How many seconds or how many minutes does it take you to get to work? How are you going to collect that data? Are you just going to trust that they tell you the actual amount of time it takes to get to work? Or do you need to actually sit in the car with them with a stopwatch? What do you do with the data once you have it? Now, we've kind of already learned a lot about that on our previous 2 units, actually analyzing data once we have all the data in front of us. But we have to make sure we understand once we have all that data, are we going to look at the proportion of people that drink coffee? Are we going to look at the average number of cups of coffee that they drink? What are we going to look at with that data? And then the other thing we got to look at is who can we generalize your data to? The whole point of looking at data is we want to learn something from it and then take that knowledge and make kind of a generalized statement. Maybe a sample of 200 people shows that 80% drink coffee every morning. So can I now say that 80% of all Americans, all people, all adults? Who exactly can I generalize those results to? Now, moving forward, hopefully we have a good understanding of what statistical studies are now. They're basically research questions. And, a research question is just the first step. Like a study is the whole process, right? Well, there's 2 types of studies. And you could do an observational study or an experiment. Both of these are going to walk you through that process of planning, conducting the study, gathering your data, doing something with your data, and then making a conclusion. All right, so let's try to answer some of these questions, right? The first question is, where do we get data from? Well, a population consists of all items or subjects of interest. So everybody that I'm interested in is my population. And a census is an attempt to collect data from every object or person in a population. But I'm going to be honest, that's usually very hard to do unless your population is very small. A sample is a sample selected for a study is a subset of that population. So usually the population is too big. Like we can't ask everybody in Ohio how much coffee they drink or if they even drink coffee. So maybe we just get a subset of that population and we call that subset a sample. Samples are usually easier and quicker to gather. You don't have to go around asking 13,000 people a question. Maybe you only do a sample of 200. And again, it just makes it a little bit more convenient for us. But it is important that samples are only good if they're selected randomly. We're going to talk a lot more about that in this unit. All right. And the goal is always to generalize what we learn from a sample to our population, right? So it's only appropriate to make generalizations about a population based on samples that are randomly selected or otherwise representative of that population. So there's really kind of two key items here. You can only generalize the results of a study based on a sample to the population that the sample was taken from. And the sample must have been taken randomly if you want to be able to generalize to the population. So if we think about our oak trees, I mentioned a question could be, what is the average height of an oak tree in a national forest? Well, if I take oak trees from outside of a national forest, well, then the question was specifically oak trees in a national forest. So if it's an oak tree outside of that forest, then I don't think I should be including it. That's not going to represent my population. I want to make sure my sample comes from that forest. And I don't want to just take the first couple oak trees I find, because that's not random. I want to select a random sample of oak trees from that forest. And only then can I apply what I've learned to all oak trees in that forest. And it was because my sample came from that population and because it was random. All right, now let's kind of dive more into those two different types of studies. We mentioned observational and an experiment. So an observational study, treatments are not imposed. Investigators or researchers simply examine data. So there's two types of ways you can examine data. You could retrospective. Retrospective is examining data that has already been collected from a sample of individuals. So maybe I want to look at some data on home prices. And I don't want to go and find a bunch of homes, so I go back and find some data that has already been collected. Maybe there's a database of home prices or home sales, and I'm just going to go back and collect my data from that database. A prospective observational study is following a sample of individuals into the future and collecting data as you go. So maybe I'm going to pick 20 houses and I'm going to follow those houses, and once they come for sale, and then I will note that the sale price is. Other example of this is with people. If I want to do a study on the smoking habits of people, retrospective would be going back and looking at records of people who have smoked and their health records. Again, something that already exists. Versus prospective is saying, all right, there are 20 people, 10 of them smoke, 10 of them don't. I'm now going to follow these people into the future and note what kind of health ailments they have or what kind of sicknesses they develop, but I'm going into the future with those people. So either way, the goal is to investigate a topic of interest about a population, right? Doesn't matter if I look backwards into the past at some previous data or if I collect my own data moving forward. A sample survey is just a part or a type of observational study, and a sample survey simply collects data from a sample in an attempt to learn about the population from which the sample was taken. Remember, that's what we're learning about here, right? We're trying to learn how a sample could help us understand a population. So sample surveys are literally used just to collect data on variables. So findings from a sample survey can only be applied to the population from which the sample was taken. So, sample surveys are really simple, right? Researchers simply get their sample and then they go to that sample and they get the data. How are they going to get that data? Maybe they just ask the question, hey, how long does it take you to get to work? That's a sample survey. Maybe I'm going to give you a survey to fill out. And there's several questions on that survey, one of which is, how long does it take you to get to work? Maybe I'm going to measure the sample. Like I said, I'm going to use my stopwatch because I don't trust what that person tells me. So I'm literally going to follow them in the morning, even if they take a bike, even if they walk, even if they take the subway, or even if they drive their car. I'm going to follow them to get a really good, accurate number in terms of how long it takes them to get to work. So a sample survey is literally just the process of collecting that data through a survey. Again, that survey could be just a questionnaire, it could be just you asking the question, or it could be maybe using some type of measuring device to actually measure the data. But if you're going to observe people and ask them these questions, or observe trees, then you need to somehow collect the data. And that's what a sample survey is all about. All right, in an experiment, it's a little bit different, okay? In an experiment, different conditions called treatments are assigned to experimental units, participants, or subjects to examine what response that treatment caused. Now, I know that that's like, what? That's kind of confusing. We're going to do an entire topic all about experiments. But the idea of an experiment is you, as the researcher, give the subjects a treatment. You give them something to do or something to take, and then you watch what happens to them, right? So an experiment could be, I take my Scott's fertilizer, I put it onto grass, and I watch the grass get greener or die. I mean, who knows what's going to happen to that grass? But I put the fertilizer on there. I didn't watch somebody else do it. I controlled that. Or an example could be if you want to test out a new pill for headaches. You're going to give the pill to the people. You're not just going to get a list of people who may or may not take that pill, right? You're going to just actually make them take the medication and then see what happens. So an experiment, there's a lot more control and imposing of a treatment. Whereas an observational study, you are literally just observing people. So let's take a look at some examples right now, because right now this may be kind of fuzzy because we're learning it for the first time. So let's look at a couple examples and try to determine what these examples are, the observational or the experiments. All right, so here's example number one. A study finds that mothers who suffer from morning sickness during pregnancy tend to have kids with higher IQs. Researchers looked at 121 children between the ages of 3 and 7, many whose mothers suffered from morning sickness during pregnancy. Rather than falling behind, experts found that these children were more likely to have scored higher on an IQ, memory, or language skills test. So what we were looking at here is we were looking at several subjects, 121 children, and we asked them a question. Did your mom have morning sickness during pregnancy? So we probably had to maybe not ask the children that, but ask their mom that. But that was a variable. Did you have morning sickness? Yes or no? And then we also measured those kids' IQ, memory tests, and maybe some type of language skills tests. And what this research found out was that kids who did have moms that had morning sickness during pregnancy tended to have higher IQ and memory scores. So was this observational or was this an experiment? Well, this is observational because all we did was collect the data. We had 121 children. We just asked them, were their mom having sickness or not? And then we saw what their IQ scores were. We didn't force anything. We didn't impose any treatment onto these people. It's not like we took 121 women and we made them get pregnant and then we made them get sick or we made them not get sick. I mean, you can't do that, right? That doesn't even make sense. It's not something you could logically do. We just looked at 121 kids and we kind of said, all right, did your moms get sick or not? And what's your IQ? We asked them questions, which is totally fine, but we just observed them. And we found out that of the kids who said, yeah, my mom had morning sickness while she was pregnant with me, those kids did tend to have higher IQ scores. So that was a research study, right? The question was, does morning sickness have anything to do with the intelligence of the children? And we found out that there was through an observational study. The second example, the students at Westford High School who worked for the school newspaper wanted to collect information on student opinions on school lunch. They selected a random sample of students who were waiting in the lunch line one day and asked them how much they spent on lunch that day and what they thought of the school lunches. They found that on average, students spend $2.75 on lunch and that 78% of kids really enjoyed lunch. So first off, this is simply an observational study. We didn't make the kids take lunch. We didn't make them wait in line. We didn't make them buy lunch. We just kind of watched and asked questions, right? Just sample survey. We simply surveyed a bunch of kids and we said, hey, how much money did you spend on lunch? Hey, do you like the lunch? That's just a sample survey. And we were able to get an average of our sample, 2.75. That's a mean. It's a mean amount of money. And we also got a p-hat, a proportion. 78% of kids who enjoyed school lunch. So we actually had a couple of different variables here. A quantitative variable, how much money did you spend? And a categorical variable, do you like lunch? Yes or no? But again, we were just collecting opinions. We were just collecting data. Now, I do see some problems with this observational study. We only asked kids that were in lunch line. If you're in lunch line, A, you're spending money. B, you probably like the lunch if you're in the lunch line. If you packed your lunch, A, you did not spend any money, and B, you probably don't like the lunch, which is why you packed your own. So if our population is all students in the school, we probably should make sure our sample represents all students, not just kids who are in the lunch line. So some kids might spend $0 on lunch. That should be factored in. Now, if our population is only kids who buy lunch, then maybe we were on the right track. But we got to make sure that we understand what our sample is, what our population is. And again, this is just observational because all we were doing was asking some kids a question. It's just a sample survey. All right, example 3. A study shows that 4th grade students who use flashcards learn their math facts faster than those who use computer-based programs. 200 4th graders participated in the study, 100 of which were given flashcards to use for 6 months, while the other 100 used a computer-based practice programs. At the conclusion of the study, those that used the flashcards got an average 12 points higher than those that used the computers on a common assessment. This is an experiment because we gave the kids the flashcards or we gave them the computer. We didn't just watch what they were doing. We took 200 kids, 100 of them got the flashcards. We imposed that treatment on them. 100 used the computer-based practice program. We gave them that treatment. We imposed it on them. And then after 6 months, we actually had them take the same common assessment. And we noticed that there was an average of 12 points higher for the kids that used the flashcards. So that's why we were able to make that conclusion that flashcards will help you learn better. So this is an experiment, right? Our research question was, which helps you learn your math facts better, flashcards or computer-based programs? And we ran an experiment where we gave some kids one thing, we gave some other kids another, and we got a conclusion. That is the difference between observational, where you're just asking questions and observing, versus an experiment. All right, one more example here. There was a headline in a newspaper or a magazine a couple years ago that said, drinking coffee gives jolt to lifespan. So about 18 years ago, researchers collected surveys from 402,260 individuals, and respondents were asked how many cups of coffee they drank each day. And after 15 years, researchers checked the death records to see how many of those respondents had died. Okay, this is just a prospective observational study. All we did was get a bunch of individuals. We gave them a survey. It simply said, how many cups of coffee do you drink? And we watched them into the future, and we checked how many of them died. And our findings were that respondents who drank 2 or more cups of coffee per day were 10 to 16% less likely to have died after those 15 years. So our conclusion was that, if you do drink coffee, you are a little bit less likely to have died in that 15 years. Now, does this mean that drinking coffee causes people to live longer? Absolutely not. Through an observational study where you're just watching people, you cannot say for certain if something will cause this or cause that. I mean, I hope you're reading this observational study right now and you're thinking, boy, there's a lot of weird things that can happen. I mean, within 15 years, there's lots of reasons somebody could die. There's a million other variables that are not even brought up in this observational study. And that's what makes observational studies a little bit kind of harder to do because you have less control. All right, so this brings up a question of association versus causation. So the response variable and explanatory variable are associated if there's a relationship between them. So the word association means that there is a relationship between them. So there might be a relationship between drinking coffee and lifespan. Maybe we learn that people who drink coffee do tend to live longer than people who don't drink coffee. But that's just an association. A causation is when we could say that this variable causes that variable. And that's very difficult to do. So there's two key points I want to end with here. If two variables are associated, it does not mean that one causes another. So association does not imply causation. Okay, so two variables are allowed to be associated without actually causing each other to change. The second point I want to make is an observational study can only measure an association between two variables. If you want to measure causation, you need an experiment. So an observational study can help us see that there might be relationships or associations between two variables, but only an experiment can show us, hey, if you use flashcards, it will cause you to learn more, or be smarter, or get a better grade, right? So the idea is that we have these two different types of studies, two different ways to go about answering questions. Observational, we could look for relationships and associations, and then experiments, we could actually show cause and effect relationships. All right, so now we got to really kind of dive into all the different aspects of all of this. This is just kind of a real quick, introduction to planning a study. Now we're going to actually talk about how to do it. So see you in the next video.